Hello everyone, we are from group 1. In this video, we are going to explain kinetic reaction for the synthesis of sodium acetate using a continuous stirred tank reactor or CSTR. The members are Anggita Jolinisea Ekarima, Nur Asisa Fajira Putri, Nurul Reski Anugrah, and I, Remigius Lalo, who is moderator from my group. So, let's get started. I give it to Nurul Reski Anugrah to explain what is sodium acetate.
Okay, thank you. I will explain about the meaning of sodium acetate and the tools used. What is sodium acetate? Sodium acetate is a colorless liquid and is commonly known as the sodium salt of acetic acid or sodium ethanoate. This product is widely used as an emulsifier, preservative, and flavoring agent in dairy product, cheese, chips, poultry, meat, and other foods. This product can be mixed with vinegar to form sodium diacetate, which gives food its spicy tasty. Thank you.
Okay, next I give it to Nur Asisa Fajria Putri to explain what is CSTR.
Okay, what is CSTR? CSTR, or Continuous Stirred Tank Reactor, is one of the chemical industry. CSTR is not only a place where the reaction takes place. It can also be used to determine the amount of conversion of the reaction that occurs. CSTR can be in one tank or more in series. The reactor is used for liquid phase reactions and is usually used in the organic chemical industry such as manufacturing plants, the pharmaceutical industry, and the food and beverage industry. The advantage of CSTR: good product quality of product, automatic control, and does not require a lot of operator power. The characteristic of this reactor is to operate at steady state with continuous flow of reactants and product. In industry, CSTR is commonly used because it operates on a large scale. The title of this research was appointed because the food industry's demand for sodium acetate is increasing every year. It is hoped that the research can help the industry to become a reference in increasing the production of sodium acetate. Okay, I give feedback to moderator.
Okay, the next is the equipment which used in the research. It will be explained by Nurul Reski Anugrah.
Okay, the tools used in the research are the one, a set of stirred tank flow reactor. The two, computer, and in the last, glass or glassware. I think that's enough. I give feedback to moderator. Thank you.
Thank you, Reski. The next is material used in the research. It will be explained by Nur Asisa Fajriya Putri.
Okay, the material used are the first aqueous, second sodium hydroxide 0.1 mole, and the third is ethyl acetate 0.1 mole. Okay, thank you. I give feedback to moderator.
Thank you, Putri. Now I give it to Anggita Jolimesia Ekarima to explain flow diagram of the research.
Okay, thank you for the opportunity. 0.1 mole sodium hydroxide and 0.1 mole ethyl acetate were prepared. The reagent bottles were filled with reagent with each solution carefully until the volume of the bottle was 50 milliliters from the top of the reagent bottle. Set point on PID is 20 degrees Celsius on the PID automatic operating model. Then sodium hydroxide is pumped into the reactor until it overflows. Then it is stopped. The ethyl acetate pump speed is set at 25, 30, 35, and 40 milliliter per minute. The steering speed of the controller is set to 50%. After a few minutes, the temperature sensor tip is at the position of about 25 milliliter of liquid in the reactor. Then the hot air circulation is turned on. The product sample was taken every 5 minutes until it was constant for titration with 0.05 mole hydrochloric acid. Then the concentration of sodium hydroxide was obtained. The procedure was repeated at 30, 35, 40, 45, 50, 55, and 60 degrees Celsius. The procedure was also repeated for the ethyl acetate pump speed of 25, 30, 35, and 40 milliliter per minute. I give it back to the moderator.
Thank you, Anggi. Now I'll explain PNID of the research. So there are two reactants, sodium hydroxide and ethyl acetate. The two reactants will be pumped into the reactor using their own pump. Sodium hydroxide with feed pump number 1 and ethyl acetate with feed number 2. To make sodium hydroxide and ethyl acetate flow different, so we add 1 point on sodium hydroxide flow and ethyl acetate with 2 points. Inside the reactor, sterile will rotate and the mixture will be heated with hot water in the circular pipe from the heating vessel. Also in the reactor, the conductivity will be measured with conductivity process, and the conductivity will be obtained and then sent to the computer. For hot water isolation, TIC will control the heater and will check the temperature in the reactor according to the set. To make the hot water circulate, the valve will be pumped. Also, the reactor has a pipe to discharge the product with sustained heat so that the reactants of it can continue to flow and not fill the reactor. Okay, that's our explanation about our topic. Thank you for attention, guys, and hope you understand our topic. Have a nice day. Bye-bye, guys.